Welcome to the first video on kinematic equations. Here we have a problem, and we're asked to find the time. So a feather is dropped on the moon from a height of 1.4 meters. The acceleration of gravity on the moon is 1.67 meters per second squared. Determine the time for the feather to fall to the surface of the moon. So this is a classic example of a kinematics equations problem. So the first step that I'm going to be using here is to identify. So I need to first identify the givens and the finds in this problem. So what are the givens? And the givens are going to be here. And I'm going to do the givens in red. Let's do the givens in red. So what are the givens here? Well, the given, we see a height of 1.4 meters. And so delta y is going to be equal to negative 1.4 meters. And it's going to be negative since the feather is being dropped, and so it's going to travel 1.4 meters. So the distance would be 1.4, but here we're looking at like the displacement, and so it's going to be the change in position. We have a negative since it's falling down. And then we have the acceleration due to gravity, so that's going to be the acceleration in the y direction. That's going to be equal to, because gravity is downwards, 1.67 meters per second squared. So there is less gravity than on the Earth. Then we want to, this is what's explicitly given to us, but there are some hidden things that are also given to us. The fact that the feather is dropped shows that the initial velocity of this feather in the y direction is going to be equal to 0 meters per second. Now, let's say that you didn't know this, and we just didn't include this for now, because you're just basically looking at the problem and just listing the givens and the finds. So I'm just gonna write the finds here, and the finds we have, let's do that in blue. We have to find the time, so that's just gonna be t is equal to question mark. Okay, so now let's just not write the hidden given for now. Now let's look at the diagram. So that's D. So the diagram for this problem is going to be something like this, and this is going to be a quite bad diagram. So let's say that this was my feather over here, and this feather is going to be dropped down, and initially it's going to have a velocity of something. We don't know, right? And we know it's going to be 0, but let's just say we didn't know. And then it's just going to drop down like this, and then the feather is going to go land on the floor, on the surface of the moon. So here, this distance right over here is going to be, and let's say that this was like the surface right here. This was the surface. This distance is going to be delta y. This is delta y right over there. Okay. And so this is delta y. And the next thing that we can also label here is we could label the initial velocity, but we don't know that technically because I didn't list it here. But let's go to the equation step, and we're going to find something that's going to help us. So when we list out the equations, we're only worrying about the y direction. There's actually technically the x and the y, but we don't care about the x because there's nothing going on in the x direction, so why worry about it? We won't use any of the x equations. So let's list out the kinematic equations. So the final velocity in the y direction is equal to the initial velocity in the y direction plus the acceleration in the y direction times time. This is our first one. Second one is delta y is equal to the initial velocity in the y direction times time plus 1/2 times the acceleration in the y direction times time squared. And the last one we have is going to be the final velocity in the y direction squared is equal to the initial velocity in the y direction squared plus 2 times the acceleration in the y direction times delta y. So these are the three equations that we can use for this problem. So notice that we have delta y. So let's highlight this. So let's underline in the colors that we have here what we're given and what we have to find. So delta y is a given, so it's going to be in red. And right over here too, and acceleration in the y direction as well. So here, and we are also, let me see. Next thing we can do is we can underline the time. So time. Okay, time. Okay. So here we have an issue here because we clearly don't know the final velocity, and it's not gonna be easy to find the final velocity, and we can't find the final velocity because if we try this one or this one, this equation or this equation, we're gonna have an issue because we can't find the velocity initial in the y direction. We don't know the velocity initial in the y direction according to our givens. So this clearly shows that we're missing something. We need additional information to solve this problem. Otherwise, it would be pretty difficult to solve this problem. So what do? We need the initial velocity, and actually that's also a hidden given. So recognizing the initial velocity exists is 0 is also important. Otherwise, you can't go and you'll hit a wall later on. So the initial velocity in the y direction is 0 meters per second. So now that we have this as another given rather, we have this, and we have this. So this is now really good. Let's ignore the equations with the final velocity, right? We don't really need to worry about those equations. So we can ignore this equation for this problem right here because we don't need the final velocity. We can also ignore this. Let me do this in white. We can ignore this, and we can also ignore this equation. This equation, on the other hand, we can use. So let's go to our algebra step now. So IDEA, all right. And so our algebra step, what I'm going to be doing is I'm just going to rewrite this equation. So delta y is going to be equal to VIY t plus 1/2 AYT squared. So again, let's try to underline the givens. This is a given, this is a given, this is a given, hidden given. This is a find. Okay. All right. So let's see. We need to find the time. So let's rewrite this. But before we use the quadratic formula to rewrite this, let's try to be smart and let's try to get rid of all the factors that would be 0. Since the VIY is 0, this whole thing would be 0. This whole thing is just equal to 0. We don't even need to worry about it. So this is just going to be delta y is going to be equal to 1/2 the acceleration of the y times time squared. Let me underline what we have and what we're given. Okay, this. Now what we have to do is we have to isolate the blue. So let's isolate that. Let's just multiply by 2, and then let's multiply by AY. Sorry, not multiply by AY, divide by AY. So let's just multiply by delta y. So 2 and then 2AY, and then that cancels, divide by AY. And then that's going to be equal to time squared. Okay. Now we have to square root both sides over here. Square root this. And remember, it's going to be positive or negative square root. But since time cannot be negative, we don't care. Let's just leave it with positive. It's fine. Okay. So this is just going to be time is equal to the square root of 2 delta y over a y. Okay, this is our final thing here. Let me underline. So this is t, and this is ay, this is delta y, and we have this perfectly here because we have it all in one side. And so this is your final answer right over here. And if you were required to solve it and go to the next step, then you could go to the next step and you could write an S, which stands for solution, and then you can plug in the values. So this would be t is equal to the square root of 2 times negative 1.4 all over negative 9, not 9.8. This is not Earth. Negative. I should have added a negative over here. The acceleration is always down. Let me make that negative. Okay, that's important. That would have resulted in a negative under the radical, which is not good. That's gonna yield imaginary stuff. So it's not what we want to work with. So this is negative 1.67. So make sure you add that negative. And it'll just not make sense if you don't add the negative. So yeah, this is the answer for this one. Let's double check. Yep, this is the answer, and we clearly have our find on one side. And the units would just be the square root of, so square root of 2 times, so delta y would be in meters, and then over meters per second squared. And then we're square rooting this whole thing, right? So it's a square root. So if we just write this, this was going to be the square root of meters times second squared by meters, and then the meters will cancel. It's just the square root of second squared, which is just going to be equal to uh, seconds, right? Absolute value seconds, it's just seconds. Okay, so it's positive. This is just going to be units. This is just a unit analysis. I like to do this separately rather than confusing it with the numbers. So you can plug this into your calculator and you can check it. This is the ideas method to solving this physics problem.